Awesome. Look at that fancy transition. Whew. That was awesome. So how many of you are C# developers? Awesome. You're all game developers. That just happened. I just turned you all into game developers. How many of you guys have ever made games at all? Like 2D, 3D? Quite a few. How about like for consoles? A few. All right, you guys win. So a long time ago, 2006, I lived in Phoenix, Arizona. And I wrote a lot of C++ code, and I made a game for the Xbox 360. I had to dive deep into the Facebook archives to actually find it. And in a little video, it's at FLV, whenever that was made. So here's my history of video games. That's all I did. This was super sweet music. So that took about 2 years, and I did that for a small company, and then I said, okay, I'm never going to do that again. Like, that was the worst experience of my life. Who wants to write C++ code over and over and over again? So I learned C#, and then I wrote printer software for 4 years. Games to printer software, natural transition. It's fantastic. I really like to say that you need at least 4 years of enterprise printer software under your belt to put software engineer on your LinkedIn page. It's just a given. Like, you have to have it. So what happened? Well, and who am I? Well, that's me. I'm James Montemagno. I'm a developer evangelist at Xamarin. I've been creating and crafting .NET applications for the last decade, ever since I moved out of the game industry. And I live in this wonderful place. It's just like Oslo, but it's called Seattle. It's lovely. It rains there too. We got that. It's cloudy, but it's also beautiful. I'm blown away. When I got off the plane, my girlfriend said, "How's Oslo?" And I said, "It's just like home." And it's actually really true. Great coffee, great people, just actually really, really beautiful. But I moved there 4 years ago because I said enough is enough with printer software, because really you can only take about 4 years of printer software. Any software developers writing printer software right now? Perfect. You all nailed it. Never do that. Never do that. Actually, it's not that bad. You learn great enterprise. Like when you are porting a legacy .NET 1.1 application to 2.0 to 3.5, and you're like, that's great. So I said enough is enough. I'm going to move to Seattle. Not only because we have the most amazing coffee everywhere, besides Oslo maybe. I'm going to Tim's tomorrow. I'm very excited about that. Like, I came to Oslo. I was like, what do I need to do? Coffee. Like, oh, going to Tim's. Very excited. But I moved there because I love mobile development. That's been my main focus. I went to the final PDC before there was fancy builds and everything like that. Got my hands on a Windows phone. I was like, oh my goodness, there's so much power in the palm of my hand. And I found Xamarin because I was a C# developer, and I've been crafting iOS and Android and Windows applications for the last 4 years. And every single thing that I do is open source, complete on my GitHub. You can find me anytime on GitHub, on my blog at james@xamarin.com, or really just on Twitter. That's the easiest way to get a hold of me. I'm up probably 24 hours a day, probably on a plane somewhere, flying somewhere. I like to say I code 50% of the time, I'm on a plane 50% of the time, presenting 50% of the time, and helping all of you guys 50% of the time create awesome mobile applications. So I'm kind of 200% always on. So we're here to talk about CocosSharp and building 2D games all in C#. But I'm going to tell you a little bit about Xamarin. How many people have no idea what Xamarin is? A few. Perfect. There's always like one or two. So Xamarin, I have a talk later on Xamarin itself with Xamarin Forms, building like native applications for iOS, Android, and of course Windows, all in C#. And the Xamarin platform is kind of actually what powers CocosSharp in a way. It's enabling us as C# and .NET developers to get away and still create Windows applications, but come over to iOS, Android, and Mac and use all of our .NET and C# skills and libraries to create great native applications. And that's the Xamarin platform. You can do that in Visual Studio or Xamarin Studio RIDE. We also have a great testing product called Xamarin Test Cloud to do automated user interface testing for any of your iOS or Android apps across thousands of physical devices. We even have a Crashlytics and analytics software for your mobile applications, and an entire training online university called Xamarin University, go figure. It has a free trial, actually, so you can actually go take a few classes for free and learn all about Xamarin and creating iOS and Android apps. And how this all works, and kind of even how the CocosSharp bits works, is the same way that Xamarin works. we enable you to build out a shared C# backend for any of your mobile applications. And these are all your business logic of your application. So your models, your view models, your SQLite databases, your calls to Azure, to AWS, or wherever you want to go. Any of your .NET code, your things that your applications are doing the same on each platform. Then we give you the tools or frameworks to build out native user interfaces for iOS, Android, and Windows. Now, I usually talk about creating just mobile applications themselves, either for the enterprise or consumer. But you can think about this iOS and Android and Windows UI up top there as just a game UI. And that's where the CocosSharp library is going to come in and replace that native kind of storyboard or Android XML with actual 2D game engines and user interface. So that's what we're going to talk about today. And there's actually several ways of building games with Xamarin, not only just CocosSharp. So if you want to tie into the actual native platforms or in 3D as well, there's ways of doing that. I like CocosSharp because I never thought I'd go back to games. And then I went to a game jam and created a game in like 12 hours, and I was blown away. And I'll show you guys that later on. But we have MonoGame, and that's actually the core of actual development. It's a port of XNA over to iOS, Android, Mac, and even Linux. It powers tons of amazing games like Bastion and Towerfall and a bunch of amazing games out, even on like PlayStation, like Transistor, for instance. So that's all in C#. We also have Mono for Unreal, which is a project that we've been working on. It's just for desktop at this point in time. But if you're kind of in the Unreal Engine type of space, there's Mono for Unreal, so you can write everything in C#, which is very cool. Built into core iOS is a few APIs that Apple gave to actually create native 2D games, and SpriteKit is one of those. If you use Xamarin to actually create your native iOS and Android applications, you get access to all the APIs. So if you could do it in Objective-C or in Java, you can do it in C#. So we expose SpriteKit and also SceneKit as a way to build 2D and 3D games just for iOS. But I think CocosSharp is kind of like a sweet spot in between because it blends the paradigms of what we kind of want to do in 2D games with C# idioms. And Miguel kind of wrapped it up, like when people ask, what is CocosSharp? And he says, it blends the power of the Cocos 2D programming model with C# and the .NET framework, so leveraging C# and .NET. And then what we did is we took what we kind of loved about Cocos 2D, and we added the C# and .NET idioms on top of it. So if you ask Miguel, why did we create C# or CocosSharp as part of Xamarin? Well, this is why, because we love the ability to kind of create 2D games with Cocos 2D, but we wanted to do it in C# in a way that .NET developers would kind of know and love with events and all the great things about .NET in the back end. So how many people are familiar with Cocos 2D at all? Nobody? Okay, cool. So let me tell you a little bit about the history of where CocosSharp came from. Well, Cocos 2D is a 2D game engine, and it was built for Objective-C developers. So they create Mac and iOS applications. And then that got ported into the cross-platform space with Cocos 2D-X, which was all C++ based. Well, that's great. Everyone loves to manage memory. So then someone said, well, there's got to be a better way. Someone then went out and leveraged MonoGame, which had already been out, and created Cocos 2D XNA, which was all in C#. But it leveraged new platforms across iOS and Android. So the first two there, the first one only targeted iOS, and then Cocos 2DX targeted Android and iOS and even Mac desktop. And then Cocos 2DXNA, which has been out for quite a long time, targeted all the platforms. Now, what we did with CocosSharp was that we took what was there in Cocos 2DXNA, and we kind of loved what was going on there. Well, we wanted to contribute actively to it, so we kind of forked it, and there's some logistics of putting things back into it with different licensing. So we said, okay, we're just going to open source all of CocosSharp, so it's available completely on GitHub. But we're going to do a few things that we thought just could be nicer for C# developers. So we did, we fixed constructors and naming and different .NET idioms, and I like to call it C#ier. It's a C#ier API. We had global state, so before you could only kind of have one Windows director, and kind of what we'll talk about here is, but you could actually have multiple screens going on. So if you're in the desktop space, actually having multiple screens. We made actions immutable. We added NuGet and PCLified everything, pickled it, if you will. Added extensions, and we like to call sanitizing the hierarchy, and I'll go over the hierarchy of a game. But we did lots of other things in a cross-platform way, like events and colors and labels, to just simplify the API. So anyone new coming in, it would be a little bit easier just to kind of get on board. So the CocosSharp API is actually quite simple, and I'll just take like a few minutes before we jump into kind of building out a game to kind of go through the essential parts, so you kind of know what I'm doing when I'm building out a game. So the scene hierarchy, you could think of anything on the screen is an active screen, and there's a few steps that you have to do to get there. So you have an application. It's any application. And that application has a director. And that director, what it's going to do, and we'll step through this, is going to direct a few different elements of what's on the screen. And usually it has one scene at a time. So you usually have one application, one director, and one scene. And that's normally what you'd expect in a game on a mobile device. You're not having multiple windows or anything like that. But since we kind of changed the API a little bit, you could actually have multiple directors here. Now these scenes have multiple layers, and each layer is consisting of certain elements, such as a sprite, a label, or a menu that might be on the screen. And then all of those layers can have multiple sprites. So for instance, you'd have multiple characters, or multiple labels on a screen, or multiple items in your menu. So this is kind of the hierarchy of the game. And what we're going to add on to is building out some sprites, which can be a flurry of different things like particle effects or just animations, and you can interact with these different elements as well. So the CC application, so you'll see all over the place, the core idiom that we put in place is CC, so CocosSharp, or Cocos, so everything was Cocos. So it's Cocos application, Cocos sprite, so you'll see that over and over again in the actual code that we'll be writing. But the application itself is going to do the hard work for you. Well, we wanted to ensure that you shouldn't have to worry about initializing graphics, drivers, or things specific for the device, or worry about OpenGL or whatever it's running on, because CocosSharp not only runs on iOS and Android, but it runs on Mac desktop, it runs on Windows, it runs on Windows Phone, Windows Store. It's like wherever you want to put it. It's everywhere you want to go. But it handles as application delegate, and actually this is the core, the beginning point of your game. And the delegate here is similar. Has anyone done iOS development? A few? Has anyone done Windows development? It's like your app.cs. Basically, it's the start of your application. So all your life cycle events for your core application. And this delegate, it's similar to iOS UI application delegate, but it does a few things. It enables us to point to say, this is where my images are, my sounds are at, so CocosSharp can reference those later. And then it also sets the first scene, but it also gives us life cycle activity events. So we can see when our application entered the foreground, when it finished launching for the first time, or when it goes into the background, so back and forth. So we get some life cycle activity for our entire application. And this is important if you're going to basically pause your game whenever your user maybe exits out of it, or hits the home button, or a phone call comes in. You're going to get this event, and you're going to pause things. So a great thing that you probably want to do is pause the sound. That's probably one thing you want to do. Or additionally, if you're going to save some state of your actual game, that's where you're going to do it at, is all in this application delegate. Now, the content folders, I referenced that the application is going to have these content folders, and we're going to put some things inside of there. And we're going to put some fonts, sounds, images. You can even create complex animations with sprite sheets, and also particle systems. So if you have particle generating tools that put out like p-lists, which kind of specify what is going on in the particle systems, you can put them right in there, and we'll take a look at those as well. And then every application, you just point at a root, and then you can say, here's the search paths underneath it, and you can even preload sounds ahead of time. So for instance, if you have an animation or the first screen of your application that you want to show and you want it launch immediately, you can say preload this content ahead of time so your assets load faster. Now, if you don't do that and you just want things to load on demand, like you're loading a game level so then load all the content, you'd want to handle that separately per level that's there. But if you have a simple game, maybe one or two screens, you could load everything up front, maybe even just put a loading screen. Then we have this thing called the director, and this is kind of that first bit. Now we're broken away from the application, now we're in the director, and all it does is handle loading scenes. So you can replace screens, switch back and forth between screens, and what we'll see here is, you might have a launch page, and then you need to go in your main level. You go to level 2, you go to level 3, and you keep directing, if you will, kind of like a movie producer. You're just directing on what the scenes are going to take place. And those scenes are the various logic portions of your application. And these all contain CC layers, so each layer of your application. So really you're going to mostly deal with a layer. The scene is only used by that director to point where you want to go. So that layer, for instance, is really important. This is where you're going to do all of your business logic. You're going to handle your game loop, your main game loop that's always running. We're going to schedule activities to occur. So maybe I want to check collision every frame or every second. Maybe I want to spawn a new enemy. Detect when a user's moved into a certain region and then react to that. And what we're seeing here in this little bit of game logic is that we're creating a new CC scene with the main window. Every application has a window. We create this start layer that's there, and then we add it to the game, to the scene. So that scene could have multiple children layers on top of it that you could direct around. And then those sprites, so those layers are going to contain sprites, and there's multiple sprites that you can have. You can have sprite sheets, so we see the monkey on the bottom there. He's actually an animation sprite, so he's actually wobbling back and forth, kind of like this, if you will, little mono monkey. So he's going to be doing that. And these are all going to be inside that content folder, and that's what's really important. We've standardized on this content folder, so you add your images on Android, on iOS, on Windows, so you could optimize the density, if you will. So even on iOS, you could do at 2x, at 3x, so you could handle retina displays, and same thing on Android. You could actually handle HD images if you're going on a high-resolution device, for instance. And each of these sprites that we're seeing here is just a CC sprite, and we'll load them in different ways. And what's interesting here is you have a cloud, and you have like this ball here, and this ball is also just a sprite sheet, but it doesn't have any animations. You could add everything into one big sprite sheet. If you've done any game animation, you kind of just snip it all out. So that way, you don't have multiple images that you have to maintain. It's just one sprite sheet that you're going to be loading up. And there's tools that we interact with. So now that you actually have things on the screen, we want to interact with it in some way. Now, of course, you're going to be running a game loop, so you can actually have elements falling or moving around or shooting a bullet, and that bullet has its own logic that's running. But if you want to perform tasks on these sprites, and we call them nodes, so each node there, you might want to tap on something or perform an action. And an action could be multiple things. An action could be a sequence. Maybe it's a spawn sequence. Maybe it's a rotation. Maybe it's an animation. And you're running these actions in parallel. You can run them asynchronously because we async awaited everything. So if you want to wait on one thing to occur, or we have a way of just streaming up a bunch of actions in a row. So for instance, maybe you tap on the screen. We want to move a monkey to that new coordinate. You want him to kind of animate over there, and then you want him to stop animating when he's done. So it'd be 3 specific actions that you queue up in a row, which is pretty nice. Now the touch events, which we're actually going to interact with as well, there's multiple events that we've given to you as developers to interact with. Normally it's just kind of one touch at a time. So if you're just tapping on the screen, you can see when all touches are occurring. You can assign a touch to a specific node. So say when that monkey was tapped or when that banana was tapped, and get a specific touch event for that. And you get multiple events, like when the touch begins, so when I actually touch down, if I move, and you'll get coordinates across the way, and then when I actually pick up off of the screen. So we enable you to get all of those. And what we're doing is we're handling all of that business logic for you automatically of you having to manually register for the different events on iOS, Android, and of course Windows. And what's really great is we even enabled multi-touch on there as well. So if you have a game that requires multi-touch and your device supports multi-touch, like almost all of them do now, you can actually have multiple coordinates and see if people are touching the screen in multiple locations. So if you're building out that type of game, totally doable. But there's a whole lot more that we're actually going to try to cover and kind of take a look at, and you'll see a little bit of this in the actual game. So we have a cross-platform accelerometer, so you can actually see if the device is actually moving and rotating. We have a cross-platform audio to play background, play sound effects, do a lot of things. We have primitives, so if you don't want to do any actual artwork in your game, you can do 100% just drawing lines and primitive graphics. And this scales across all the different platforms. So if you're going to do like a Geometry Wars clone, for instance, you could totally do that. We have advanced particle systems, so you can spawn particle systems, and those are caked in. We have a few for you automatically. But you can pull in your own particle systems and just spawn them off and have them do whatever you want. So for instance, you could just keep spawning a background image that's just doing crazy stuff and firing off or rotating over and over again. We have parallax, so as you see, as the monkey moves up and down, the actual clouds are moving with it. So you can say, I would like that as this monkey moves, keep it to be a specific, I'll go back and forth so you can see it again. I want to parallax those actual clouds. So you kind of link those two objects together to move them around, which is really cool. And it's handled all for you automatically. We also have multiple effects, so we're doing like wavy type things and spinning things automatically. And we'll see that. We're actually going to set up some effects to actually spin this banana and move this ball around and move it around on the screen. And finally, we have a very advanced physics system in the actual game logic as well. So this actual box that's kind of moving, it'll actually handle the physics of gravity for you automatically, kind of in a world space. And all of these little samples that you're seeing here are all available actually on our GitHub repo, because everything is open source. We actually have one huge solution that has like every single sample and use case. So it's like if you want to try to do something, we have a test for it. So that's kind of the core of CocosSharp. There's a lot in it. There's a lot of text kind of on a slide. But what I wanted to do is just kind of build out a game and take a look. So we wanted to get started, and I'm going to do everything inside of Visual Studio. You can do everything also inside of, I'm going to do it in Xamarin Studio. You can also do everything inside of Visual Studio. And I'm just going to focus on iOS and Android. But what you'll see in the actual business logic of the iOS and Android application is that there's 3 lines of code. So if you want to bring your application to a new platform, all you have to do is copy the image assets in, add 3 lines of code, and you have a game. It's pretty awesome. So we kind of start, and I like to start everything actually on GitHub. So this is the GitHub, and I'll zoom in here for the GitHub. It's github.com/mono/CocosSharp. Now we put this on the Mono directory because it's kind of built on MonoGame. It's open source, and actively people can contribute to it, especially if they're on the Mono project. And that's kind of what we're actually doing. Xamarin, we're the creators and the maintainers of the Mono project, which is the original open source implementation of .NET, and that's what we're actually leveraging here on iOS and Android to bring that over to create iOS and Android apps. I'm going to pull this down so this doesn't fall. There we go. Cool. So if you want to see what we're doing and have issues or want to have pull requests or look at the wiki, everything is here. So every single bit of the entire CocosSharp library is actively here, including you can load this up on Android, Mac OS. We have Ouya support, and then all different types of Windows and Windows 8 and phone support as well. You can see what we're doing in here. We have a forum, so if you want to actually go and actually maintain to it, actually have questions, we're active there. And we have this wiki, and everything is under MIT license, which is really great. And the wiki, it kind of gives you everything how to get started. More links to the forums, we have a Slack channel, and we even tell you if you want to deep dive on why we created it, what the core differences are, and getting active with the new Git packages, and look at what we're doing in the future as we evolve CocosSharp. Everything is going to be documented here. Now, what we did is we created some project templates. So I like to go over here, and you can see there's project templates in our wiki. And the project templates, all it does is tell you how to get started in either Visual Studio or Xamarin Studio. And in Visual Studio, all you do is just kind of download a project template, it's a VSIX file, into the extensions. And that kind of gets you good to go over there. Now, if you're inside of Xamarin Studio is our IDE. It's built and it works on both Windows and Mac. It's a lovely IDE. It's very similar. We built it with the Visual Studio developer in mind, so all the key bindings are the same across the board. It looks very much like an IDE. We have built-in source code analysis in it. If you've ever used Xamarin Studio at all, we have this thing called an add-in manager, very much like Visual Studio's add-in manager. But when you go over to Gallery, there's a CocosSharp entry, and all you do is install the project templates, and that'll kind of get you up and running to do iOS, Android, and Mac development for CocosSharp. And that's really convenient. So once you have that installed to get started with CocosSharp, you're going to hit New Solution, and under App, we're going to see some brand new templates in here. There's CocosSharp Showcase and an empty project. So we're just going to kind of do File, New Project, see what that looks like. So we'll say NDC CocosSharp. There we go. Now we distribute everything through NuGet. So everything is just a NuGet package, and on up top here, it's going to add a bunch of packages for me automatically over and over and over again, and we'll probably even update them. Let's take a look here. Oh, it's good. Let's see what we're on. 140, perfect. This is actually pretty nice. It's going to, okay, got everything. Awesome. So inside of here, what we have is an Android project, an iOS project, and a common lib. And that common portable class library is going to handle all of our game logic of our application. And we can just see that there's just a CocosSharp PCL inside of here. So the main app delegate that's here, this is going to handle kind of our business logic, starting our application. So we can see that the application finished loading. And inside of here, it sets up kind of some default state for us to say, hey, I have a content folder. There may be some animations, fonts, sounds. I really like this to be 1024 by 768, but it'll handle the scaling for you automatically on these different devices. If you're an Android developer at all, you know, it's a crazy, crazy, beautiful disaster over there of a bajillion devices. We handle all that for you, so scaling or putting borders around your game for you automatically. And then here we'll actually handle high density or low density images. And then it starts and creates a game layer, adds that child, and it runs with that scene. So that's the start. And we can see we even have a little pause state inside of this that you could check at any time. Then we have a game layer. So this game layer is going to do a few things. It's going to load up some sprites. And if we look actually inside of this content directory over in iOS, we'll see some images in here, HD and low-D. It's just a monkey that's inside of here. There he is. Adorable. So it's going to load up a few monkeys, add it to this layer. So this is a layer, a CC layer gradient that's in here. So that every single one of your screens will be some sort of layer, a solid color. You can add a background, or this one's going to be a gradient. We're going to create some of these CC actions, and the default there, we have some move by. We're going to create a sequence of repeating it, and we're going to spawn this effect, this wave effect. So I'm just going to kind of run this so we can kind of see what it looks like. I'm going to select an iPhone 5S simulator. Let's see what this looks like. I'll go ahead and spin up there. So it's nothing too crazy. It just kind of shows you some things that you can do. So loading some sprites, putting them on the screen, and kind of moving them around. We're also generating a particle system in the background. And what I can see is if I want to interact with this, I can tap on the screen, and that particle system moves. So I want to kind of show off the core of what we're going to be doing when we actually build out a game. So up here, what we'll see, where's it at? Down here, run with, there it is. We have this event. So we created an event, which is a listener to say whenever anyone touches anywhere on the screen, I could subscribe to multiple touch events. So there's on began, on canceled, on ended, and on moved. And whatever I lift up here, we go in and we run this touches ends. And what we can see that all I'm doing is this galaxy system that's creating all these particles. I grab the first touch event, grab the location. If it was moving, I stop it and I say, let's move it somewhere else on the screen. And then I tell it to move over a certain amount of time. So over this duration, move it to this position. So really, really simple. And I run this action. So everything's action-based inside of here, which is really nice. So that's what is going on here. So if I move this around, we can see it's just kind of moving around on the screen. Now, if I load this up over on Android, we can take a look over here. So let me go and pump up an Android simulator real quick. Now I'm going to be using our Xamarin Android player, which is a free emulator from Xamarin. Anyone can use it for any type of development on Mac or PC. It's all based on VirtualBox, so it's really, really fast, which is really, really nice. So let's see if this will spin up here. So we'll go ahead and pop it over here. Just make sure I have everything set up correctly in my build actions. Nope. Oh, got an email. Perfect. I like that. There we go. And what we see is actually in the iOS or Android application, we have our actual iOS app delegate. And this is kind of the start of the application. So I'm creating that shared app delegate. And then over in, I got to rotate it. There we go. Then we do the same thing on Android. But it's the same exact game, same image assets, everything like that now over on Android. I didn't actually write any Android code. I just everything in C# because I'm using CocosSharp. So if I look at Android over here, we can see that I'm using some packages, CocosSharp Android. In my main activity, what do you know? I just have a little bit of configuration and I start the game. That's it. So even if you don't know Android or iOS development at all, you don't really need to because you're just learning the CocosSharp API, and it's just going to run over there. Now, if you want to tie in, for instance, into like Google Play Games or the iOS equivalent, I forget what it's called, Game Center? Game Center? That sounds right. You can actually add that integration. If you want to put it on Amazon devices, you could download the Amazon SDK and put it right in there. And the same thing would be true over on Windows. You would just pull in the CocosSharp Windows NuGet package, add these same lines of code, and then you could integrate with anything you want. If you want to integrate in Cortana or something like that, you absolutely could, because you could just bring in those packages. So let's actually open up another game and actually build some things out from scratch and walk through kind of building out a game. And the kind of sample you saw with that little monkey kind of moving around and collecting bananas, that's a game that we have called Gone Bananas. Go figure. And we're big fans of monkeys, as you can see. This is Sebastian. He's up here hanging out with us today. And this Gone Bananas is available for every single platform, Windows, iOS, and Android. And I've just opened up the iOS and Android bit here. And what we're going to notice is that we still have an assets folder, and we have content inside of here. I added some custom fonts into my application, some sounds. I have an MP3, and I have some WAV files. And then I have an animation. So if I open up this monkey here, this is that same thing. We've even stuck the banana in there so we can pull it out. It's just a sprite sheet. And then I have this P list, which was generated by a tool for me. If I open this up, I think here, let's try to open it. There we go. It's just keyframes. So it says what frame do you want to use per. So it's just like spits that out for us. And then we have the balls. There's the balls that we're going to be dropping from the sky. And the idea is that these bananas and balls are going to fall from the sky. We want to collect the bananas. If the actual balls hit us, then the game's over. But we also have this background that we're going to use, grass, and that'll be kind of nice. All right, perfect. So that's everything that's inside of my core application. If we look at the app delegate again on iOS and Android, it's going to be the same, except we're going to create this Gone Bananas app delegate. And that's what's going to start here. And I didn't want to write a few hundred lines from scratch, so some of this code is in place, some of it we're going to write out, but it's going to look very much the same. We can see that I'm preloading some effects, sound/tap, sound/background music. I'm just grabbing the main window size and setting that as the default, and I'm running the game. And we're running this start layer. So there's three screens to our game. There's a start screen, a main game loop that's going to run all of our business logic, and an end game. And we can loop those back and forth. So the start of our game here, if I open up the main game layer, is pretty simple. I have a click handler, and all it does is whenever I touch anywhere on the screen, it'll start the game. It's going to start my main game layer, and I just add that touch listener. I have a black background, and all I do is put a label. We create a CC label, and you can, by default, just slap down some text, load up custom fonts, and we can see I have Arial in here because I brought in Arial. You can set a specific size, and then you say where you want to do it, and I'm just going to align it in the center and add that in. And that's it. The main game layer that we're going to interact with here is going to do a bunch of stuff, and we're going to kind of walk through this later. But when this is over, what we're going to have is a game over layer, and these two are kind of already caked. And all this one does is it looks very similar to our first game, but it takes in a score, so I could display a score on the screen on there. And I have a score label and a play again label. Whenever they tap it, it just brings them back to the previous screen to start a new game. So very, very simple inside of here. And that's it. All right. So let's go into our main game layer. And that's where all of our action's going to be. And I set up all my variables ahead of time. So how fast do I want the monkey to move? How long does my game last, which is going to last 60 seconds? And how many maximum amount of balls do I want on the screen? We have some physics. I'm not going to go into physics logic because I'm not a physics major. I just kind of put that in a helper class. But we have a bunch of physics that's going to happen. And then we can see what else I'm doing here. So first I'm going to set up what I want to track in my game, so the elapsed time. So after 60 seconds, I should end my game. That's going to be a goal. I'm a main monkey, and I'm going to interact with, so that's going to be a main sprite. He's just going to move around and animate on the screen. And then what I'm going to do is I'm going to keep a list of visible bananas and hit bananas. So the idea here is that I can just kind of track and actually see the rotation and check the collision of any visible bananas on the screen. And then the hit bananas will go into a list that I could track later that I've removed from the scene, and I can get a count for them later on. And then I'm going to kind of start setting up my game. And some of these are just animations that will be played, and we'll set up. So we have a walk animation, and we'll set that up in a bit. A walk repeat, so it'll loop forever animation, and a way of stopping it. So this just says, hey, on any node, stop all actions. That's a little extension method. So you have a way of saying, if you're moving, stop right now. Just stop walking, stop doing whatever you're doing. I also have a sprite, just like we had our monkey. I have a grass, so that's going to be our background sprite. I have a rotation, so I say over 0.8 seconds, rotate the banana 360 degrees. We handle all of that logic for you. You don't have to worry about it. We'll take your sprite and rotate it just with this action. And then what we do is I set up a little action, just like we said, stop all actions when I want to stop walking. Also, remove this banana when it's done. So I'll remove the node, that banana node, from the parent. So I'll just remove it from the game scene if I collide with it. And that'll be any node. And then I set up my balls that are here in my physical world. So I have a little bit of logic just initializing. And we're going to walk through adding some things side by side. But I just wanted to do a little bit of setup here. So I have my touch listener, touch all at once. And that's whenever I end and pick it up. I set my background color to white, initialize my lists. And in this instance, I'm going to create that sprite batch, so those balls were in a batch file basically inside of there. I'm just going to pull down that texture and split it all up so I have my balls ready. And then I'm going to add grass, add monkey, and start scheduling. These are all blank, so we want to fill those in. Now all we need to do at this point is actually start adding some things to the screen. So let's go ahead and do a few things. Inside of here, let's remove our monkey so we can kind of add one thing at a time. So we're going to add our grass, and our grass is just going to equal a new CC sprite, and it's going to take in a file name. That's going to be grass. There we go. Or I should say, let me just run this first so you can see what it looks like. I think this should run. Let's take a look. Boop, boop. So I haven't really done anything, just initialization, and hopefully if I didn't crash anything, it shouldn't do anything. Perfect. There's tap screen to go bananas, and it's white. So that's what we have. That's our game right now. We're going to transform this over the next 20 minutes. So we're going to add some grass. So first what we'll do is we'll initialize that grass, and then we'll say add child to this layer. And there's grass. Now I do get some event. I get my application event lifecycle, but each layer also has some event life cycles as overrides. And we're going to see whenever this was added to the scene, whenever this layer was added to the scene, I can initialize a few things. So I'm going to go ahead and position my grass right in the middle. So we can run this again. So I create my grass, add my child, and run it again. Grass, that just happened. 2 lines of code, not bad. Let's put our monkey down on the screen. So here what I'm going to do is, this is a little bit more logic, so I didn't want to write this from scratch, but I'll walk through it with you. So instead of creating a sprite, this monkey is a sprite sheet with all those animations. So what I have to do, I'll go ahead and pull this down a little bit. We have a little inline function here. But I'm going to say, load up that animation plist info, that sprite sheet that's going to have the different keyframes, and grab all the animations that start with frame, because there's frame 1, frame 2, frame 3, frame 4 for each animation. And then I'm going to initialize a few things. I'm going to animate and create an animation. So I take all those keyframes and I say each frame should last 0.1 seconds, so he kind of moves across the screen. And that's the main animation. And then I'm going to create a repeat. So just keep animating that walk animation over and over again. So there's an animation, and I tell the action is to animate the animation and repeat that forever. So just kind of always keep doing that. And the last thing that we're going to do is create my monkey based on just the very first sprite in that list. Give it a monkey name. And then I scale it 0.25% because it's a really big monkey. And then I add that monkey to the list. And that's it. So we have our animation that's going to be looping over and over again, and I create my monkey. So now I can also put the monkey right in the middle, load it up again. Now we got a monkey. But now, of course, we want to do something with the monkey, because if I tap on the screen, I'm actively tapping, nothing's happening. So let's move him around a little bit. So we saw earlier, if we look up top, I created this on touches end. Here it is. It's blank. I have it down there in case of emergency. We're going to try to type this out. So every time I move, we want to move that monkey to a new location, and we want to animate him. So the first thing that we're going to do is we're going to say, monkey, let's stop all of your actions. So if you're moving, if you're doing anything, if you're rotating for some reason, stop doing that and calm down. Then we're going to grab our location, and that's going to see we have a touch event, so we can see which touch event came in, but also a list of CC touches. So we'll grab our first touches out of that list, and we'll grab the location on screen, so the physical location on screen. And then what we need to do here is we need to take that location, and we're going to call a method called world to screen space. And what that's going to do is it's kind of take the current location on the screen and put it into our world that we have here, so I can manipulate it. Now we have to do a few things. We don't want all of a sudden to say, move that monkey over there in 0.1 second, and he goes racing across really fast. Or maybe he's only moving just like a few pixels. So we need to calculate how fast this monkey should move. So what we'll do is we'll create the distance. So we'll calculate the distance here. So we'll just say distance. And we have some helper methods inside of here on our point. So there's a point x and y coordinate. There's a distance. We can calculate the distance between 2 points. That's pretty lucky. So we'll say monkey.position, where you're at right now, to our location, and we're good to go. And then we'll say speed there. And we'll take our distance, and we're going to divide that by our monkey speed. So it's going to kind of normalize our speed over distance ratio. It may not be the best math in the world, but it works for this sample. Now we need to actually go ahead and actually move our monkey. So we have some moves in here. We can move by state, move to a state. So we're going to move to over, we'll do it over that speed. Or sorry, this is calculating the time. That's my fault. Sorry, time. The distance divided by speed, that equals time. Yeah, I think calc, math, it's been a long time. So one thing I forgot about game development when I was starting all this, like, oh, math. And we're going to move that to the new location. There we go. And we're going to tell our monkey a few things. We're going to tell our monkey to start animating. We're going to tell it to move. And then at the end of it, we're going to tell it to stop animating. So we'll first say run action. Monkey, oops, that's not it. Say move to. There we go. Monkey dot start. Where'd it go? Run action. There we go. Run action. There's run action async. Run multiple actions. And we're going to tell it to walk, repeat. Then we'll say monkey dot run actions. So we're going to run 2 in a row. So this will pair them up. So it'll always walk repeatedly. And then we're going to run some other actions. So we're going to say move to first. And then we have a walk animation stop. So we're kind of chaining up multiple events. We're going to say, hey, run this first animation and keep running it. That's our animation that's looping over and over and over again for him walking and animating. And then run the action to move to that location. And then what this does is when we're done, it'll run the next action automatically. But we're running them in 2 separate calls, so it's always walking and repeating over and over again. So let's run that again. There's our monkey. I'm going to tap up top. Boom. If I zoom in, you can see him moving around. Pretty adorable. Pretty adorable. All right. And that's your game. Done. No, I'm just kidding. All right, so what do we need to do next? So the next thing that we need to do is actually schedule some things. So we've added our grass, added a monkey, and then we need to schedule some things. And what does that mean? Well, every game that you ever create has a main game loop. And the game loop is always running every single frame, and you need to update it. So what we did is we enabled a way of scheduling things. And you can schedule, it's kind of like a tasked-out run almost. But what we said is keep running this task at certain intervals in time. And you can schedule up a bunch of actions over and over and over again. So if I come down here, after this, we have this start scheduling. And I kind of lined up what I need to do. So the first thing I need to do here, and my start scheduling, is I need to schedule a banana. I need to schedule to add a banana to the visible bananas list. I'm going to add some time to our game loop. So I'm tracking up to that 60 seconds over and over again. I'm going to check to see if the game is over and then go from there. So down here I created a few helper methods. We have is time up, pretty simple math. Is the elapsed time greater than the game duration? And then I also had this add banana thing. And what this is going to do is it's going to load up our sprite sheet, take out the banana that's in there. It's going to use a helper method to start in a random position. So I have a bunch of helper methods that I'm not going to go into. It's a bunch of more math and logic and shenanigans. So we'll just pretend that I went over that. It's all the stuff's online. We're going to grab a random position. We're going to start, and here's the banana on the screen. Add it. And then similarly, like how we were moving the actual monkey on the screen, we're going to do the same thing. We're going to move the banana down to the bottom of the screen. And then when it's moved to the bottom of the screen, remove it from the view. And then always rotate that banana over and over again. So you're going to see it spinning on the screen. So let's just do that. We'll come up to our schedule, and we have a keyword called schedule. Now, don't be worried. We're going to actually put some inline actions inside of here. We're going to use this one. It's going to take a float, which is the time that it took in between the last call, and an interval. So we'll say t, and we'll just put a little stuff in here, and we'll do auto 1.0f. So every second, we want to add a new banana to the game. So we'll say visible bananas.add. We're going to call that add banana. There we go. We're going to say our elapsed time plus equals t. That's a time difference between there, so 1 second, 2 second, 3 second. But it's always 1 second, so we could change this, and this could be variable. Then what we're going to do is say if is time up, let's end game. Now this end game method is down here, and I haven't done anything. We're going to do that later. But our core business logic is in place, and we can start it up again and just see what the scheduler is going to do over and over and over again. And if we're lucky, a whole bunch of bananas should fall from the sky. Boop. And that's pretty cool so far. And it's just doing it all randomly because I'm kind of getting a random X in there. And that's pretty cool. All right. So let's do another thing. Let's go ahead and schedule another one. So we'll say T, and we'll come in and we'll add a ball now. In here, we'll do that every, I'm going to do every 0.15 seconds because it's pretty hard with 0.1. And I have a add ball method. And that, of course, is going to be over in my little helpers class. And what this is going to do is it's only going to add the ball if we don't have our maximum amount of balls in there. So the balls are always going to kind of be there. It does a whole bunch of 2D vector stuff to kind of like bounce around, so it bounces up and down off the physical world space that's created. More math, don't worry about it. Games, don't worry about math. It's not important. So we'll run that again. It's actually very important. Learn lots of math. Cool. So we'll tap again. And now what we'll see is now we have a ball. But the balls are just kind of at the top of the screen because we haven't animated it at all yet. So we need to do that. But they're there. They're occurring. That's interesting. Boom. All right. We're almost there. All right. We could do a few things. We could schedule every second to do something. We'll say, hey, just every frame. It could take in just an action. We'll say check collision inside of here. Now check collision. I have to do T. Let's do this to make it easier on myself. There we go. Now check collision. There we go. Is another helper method that I wrote, but it's actually really not too difficult. What we have inside of here is bounding box transformations. Now, bounding box might not be the best because it's a monkey with a banana, but we have actual documentation of how to actually put multiple bounding boxes around that monkey. So you might want to do the banana, then the actual body inside of there. But for simplicity's sake, I'm saying for each visible banana in the list, if the bounding box that's transformed around it interacts with the monkey, then that banana is hit. We're going to play a sound effect called sound/tap. We're going to explode that banana. We're going to actually do a particle, and we'll look at what that looks like. And we're going to remove it from the parent. And this explode thing here is actually a particle explosion. We have a bunch of them caked in automatically, but this one just says create and do an explosion of particles, create 10 of them, and automatically remove it from the scene when you're done. That's it. But really just doing collision, just looking at the core collision that you have, like that's pretty simple math. Just every frame, loop through my visible bananas, and be good to go. Now, of course, kind of best practice, if you have 1,000 bananas on the screen, that's going to be pretty difficult to check every frame. So you might want to actually do some more logic inside of there with like link or something. Because link's super fast, right? So we'll check collision, and we'll still see that these balls are up top. That's cool, but this is going to like make the game really, really great. Because we're only just checking the bananas. I'm just going to win forever. So let's see here. So now if I actually tap here, boop. This makes the game easy to win. Perfect. So now we got some collision going on. We got some particles happening with just a few lines of code. Now we need to schedule a few other things. This one's a little bit more difficult. Because what we're going to do is we're going to loop through all of these balls on the screen. We're going to do the same kind of detection to see if I actually am inside the physics body of the specific ball. And if so, I'm going to remove that sprite, and then we're going to actually move around on the screen. It's a little bit more complicated, but this is going to move the ball and destroy the balls when they're not moving. So it's a little bit more math inside of there. So let's take a look here. So now our balls are falling. And that's bad. Let's see if I did put any collision. No collision yet. Cool. Perfect. So now what we need to do is actually do a few more things, which is end our game. So we have our balls, we have our things occurring inside the game, and then we can actually end our game if we hit a physical or a ball on the screen. So we'll unschedule everything, unschedule all. We're going to create a new layer. We'll call our game over .scene with score. We're going to pass in a main window. There's our window, and we'll take in our score, and that's going to be our bananas. No, what is this called? Hit bananas.count. So how many we hit, and then what we can do is say, what do we have to do? It's the director thing. Sometimes I just forget core logic. Window.default director. There we go. Window.default director .scene. Replace scene. So we're just going to move, and we're going to move to this new layer or scene, if you will. And that actually should be scene. There we go. Perfect. And there we go. So that should be good to go. Now I need to double check to see why my check collision is here. Hit bananas, ball count. Good to go. Balls, hit, count, end game. Great. All right. So check collision, it does a little bit more than that. It adds and it updates the hit, and then it also does some detection here on the bounding box of the actual balls that are on the scene. So now we can move this again. Now ideally I should be able to kind of get some here. And then boom, I hit the ball because it's interacted with it, and I got 2 bananas. If I tap again, I start up a new game, and we're kind of good to go. Now it's kind of boring because there's no background music. That'll really spice this up, I'm pretty sure. So let's go ahead and add that. So I'm going to come up to the top, way up top here, into my game layer. I'm in the right scene. There we go. And after we set and start scheduling, we're going to use this thing called CC Simple Audio Engine. We're going to use the shared audio engine. So anything that's kind of all the sound effects and our game music that's there, we can adjust the volume. We can also play background music. And if we take a look inside of here, what we'll see in our content, sounds, we have background music. So we'll say sound/background music.mp3. And we'll loop that. Why not? Boom. 1,000 times better. Basically, best game ever. Which is pretty cool. Not even moving. Let's see how I'm just going to dodge all the balls. That's a pretty awesome monkey right now. I'm just like, oh, there we go. Pretty good music. I think we bought that for like $1. I'm sure. All right, so what's really cool now is that I can now just set Android as my startup project here and actually select that same Android device, the emulator that I had there. Let's rotate it back. This is a portrait game. The same exact game, same particle physics, everything is reused 100% across the board, and this is scaled down, obviously, so I scale this up. But it's a full another game on Android, no additional work that I needed to do, because everything is in my core portable class library with CocosSharp, which is pretty mind-blowing to me overall. And you kind of have a full game with just a few lines of code, some math and some physics, but besides that, it's all there. We can all figure out physics. It's easy, right? Cool. Now, all of this source code and more is all available online, and I'll have these slides on my slide share, but you can just always tweet at me. But it's also all on that Coco. So when you go to the mono/CocosSharp repo on the Mono GitHub, there's also the CocosSharp samples, and there's tons of games in there. Not only just this one, but there's an extension to Gone Bananas that actually has Apple Watch support, so you can control the monkey from the watch, which is really crazy, which is really cool. It's actually published. It's called Gone Bananas. It's on iOS and Android by one of our evangelists, previous evangelist, Mike Bluestein, because he created this sample, which is awesome. A whole huge walkthrough of creating this step-by-step. I didn't even go into the parallax or creating the sun with the spirals in the background, everything like that. There's a lot of cool additional stuff that you can create. I'll let everyone take a second there to take these snapshots. I'll tweet these out later as well. I'll have the slides online if you follow me on Twitter. Now, a lot of people ask about pricing, like what's free, what's not free. Well, CocosSharp is open source. And if you want to create Windows applications, you don't pay us for that. You pay Microsoft for whatever you want to do. If you want to create games with Xamarin and CocosSharp, it does cost some money, some subscription to do that. We have an indie edition starting at $25 a month for iOS and Android to publish your game. But to do it on Windows or anywhere over there, you're good to go. Once you have your Android or iOS application, you're paying us for the compiling, the technology to bring that over and build the iOS and Android app. If you haven't gotten started with Xamarin, just playing around with it, go to Xamarin.com. We have a full 30-day trial. I did mention Xamarin University earlier. We have tons of great stuff. I have some Xamarin stickers and some Pluralsight stuff up here. There's tons of great resources, including our documentation to get started. But we just yesterday, I'm super excited that we did it yesterday, not tomorrow, but we have a full 30-day trial of Xamarin University, which is live interactive instructors that go online in a GoToMeeting, and you learn 24 hours a day, 7 days a week. And it's like you're like a student, you become a fully Xamarin certified developer. The free trial gives you a few courses and access to all of our guest lecturers. I was just listening to Miguel de Acaza, our CTO, on one of our guest lectures talk about just the state of .NET. Is really intriguing. I did that before I went to bed, which is really cool. So I recommend everyone checking out Xamarin.com/university because it's free to do a free trial, and there's no credit card or anything that you need. Of course, you can find me at any time just at james@xamarin.com and at James Montemagno, nice short and sweet Twitter handle. And I have a Xamarin Forms session in this room at 16:20, the very last session of the day. Yeah. So with that, thank you guys so much. I'll be around as well up here if you guys have more questions. I have some Pluralsight stuff and stickers as well.